Hello guys, welcome to my channel. In this video, I will talk about the Monty Hall problems. So, here's our problems. Suppose you are in the game show and you have the right to choose one of these doors to open. And behind this door, there is the car and two gold. A brand new car and two golds. So, for example, you pick the door number one, and the host will tell you, you pick the door number one, I will open the door number two or number three. And suppose the host opened the door number three, behind the door number three, there is a goal here. There is the hole behind door number three. So your challenge here is the host step to you and ask you the questions. Do you want to switch from the door number one to the door number two, or do you stay with the door number one? Some people are very confused. They want to stick the door number one. However, the real answer is you should switch from the door number one to the door number two to have a higher chance to get a brand new car. So why you should switch from the door number one to the door number two in these situations? I will put math in this problem for better explanation. So I will use three diagrams for easy to understand. Yes. For the first time, the first choice, your choice here. You could choose the door with the car, the door with the gold A. I say that the gold A, so the gold B. Okay. When you choose the door for the first time, the host will open one or two doors left. So if you choose the door with the car for the first time, there are two doors left here with the gold A and the gold B. And similar for this case, you have two doors left with the car and the gold B, and you have two doors left with the car and the gold A. Now, for the first time, you have three options with the 1/3 probability. Yes, it's simple. And after the first time, the host will open either the door two or the three in these situations. So the probabilities for the host to open two doors left is equal 50-50 for each three case. So the probability here is 50-50 is equal. It's equal here. Okay. So the probability you get the car for the first time and the host open here is 1-6. It's equal. So because the probability is equal, so some people are very confused. But here's our problem. The host always know which door have the car and which door have the goals. So in this case, When you choose the right door with the car behind, the host know. The host know you choose the right door. You choose the right door, but you don't know because you're not open yet. So, if you choose the right door with the car behind, the probability for the host open 2 door left is equal, because you always remember that the host always does not open the door with the car behind. So in this situation, the probability for the host to open the door is 50-50, the same. However, for this case and this case, because the host always know which door has the car, so the probability here, the probability is that for the host to open the door has the car is zero. Is zero. Yes, is zero. Because the host always does not open the door has the car, because you are in the game show. If the host open the door has a car, yeah, I open the door, it's the car. It's not funny, it's nonsense. It's not a game show. So the probabilities for the host to open the door with the goal B in this situation is 1. And similar for this case, the probability is 0. And the probability here is 1. Now, the probability here is we change. It's remain the same, but in this situation is 0. And here, I will, yes, here is 1/3 is 0 and it's 1/3. Now, in this case, you pick the right door with the car behind. The probability you get the car is 1/3 plus 1/3 is equal to 1/6 plus 1/6 equal to 1/3. It remains the same for the first time if you pick the right door. However, in this situation, the probability that the house not open the door with the car behind is 0. Is 0, is 0. So the sum of probability here is 2/3. The 2/3 mean that the probability you choose a goat and the host open the goat, which means if you switch after the host open the door with the goat, the probability you get the car will increase from 1/3 to 2/3. It's double. You should switch. That is very easy to understand. Now I will do another approach, another explanation with more mathematics. Yes, I will erase this. And the tree diagram is very easy to see. It's not tricky. And you know that you always remember that the host always know which door has the car and which door has the goal. Now I will do another explanation with the Bayesian's formula. I will call A. A is the event. A is the event. You choose the door with a car. So the probability of A is 1/3. That is, it's very easy. It look like the probabilities of the first time in the three diagrams. And B is the event that the host open the door with a goat. Okay, so remember, the host always know which door has the goat. So the probability of B is 1. It's look like the two case in the three diagrams. The probability that the host open the door with the goat is always 1. Now A and B are independent events because the host always know which door has the ghost. Now A and B independent event. Okay, so the probability of B given A happen, this is the conditional probabilities, is equal to the probability of B and equal to 1 because A and B are independent events. Now your question is the probability you get the car given the B happen. The probability of A given the B happen, which means is the probability you will get the car given the host open the door with the goat. Yes, okay. P A given B happens is equal to PA multiple with the P, the probability of A, multiple with the probability of B given A happen, divided to probability of B. Now you use the number. It's very easy. Just some little calculus. The probability of A is 1/3. The probability of B given A happen, which means that the probability that the host opens the door with the goat given you choose the door with the car is always 1. Remember, the host always know which door has the car and which door has the ghost. Multiple with 1. Okay. Divide to the probability of B is 1 and is equal to 1/3. So the probability you choose the door with the car given the event that the host open the door with the ghost. This number is look like the number 1/3 in the tree diagram. So if you switch the door, the probability you get the car is 1 minus 1/3 is 2/3. That's it. You increase the chance to get the car if you squeak the door. That is very easy to understand. That is all the problem. The Monty Hall problems. Thank you for watching this.